Hello and welcome to a new video. The cosmos is populated by monsters, but none command more fear than black holes. Tears in the fabric of reality from which nothing can escape. In this first part, we are cataloging every distinct type of black hole that we know actually exists. We are going from the standard stellar corpses to the ultramassive giants that defy our comprehension of scale. We are starting with the confirmed reality, the ones we can observe. And make sure to watch until the end, because we will reveal the one physical truth about black holes that textbooks often get wrong. Let's get started. Category 1. The known standards. Here, physics is still understandable. These are the holes we can see or measure. One stellar mass black hole, the standard. Let's start with the classic, the stellar mass black hole. This is the type we discovered first, like Cygnus X1. These holes are the actual corpses of massive stars. Specifically, when a star at least 20 times the mass of our Sun runs out of fuel, it can no longer support its own weight. It explodes in a violent supernova, and the remaining core collapses inward with such force that it punches a hole in reality. Visually, they are terrifyingly simple, a perfect black sphere. The shadow often surrounded by a swirling, superheated accretion disk are simply visible because they bend the light of the stars behind them via gravitational lensing. They aren't actually that big often, just the width of a large city, but they pack the mass of 20 suns or more. And it is exactly this compactness that makes them so dangerous. If you get too close to a stellar black hole, you experience arguably the most famous way to die in the universe: spaghettification. That is not a joke. It is an actual physical term, because the hole is so small and the gravity changes so drastically over short distances. Your feet are pulled much harder than your head. The difference is so vast that your body is literally stretched into a long noodle before you even reach the event horizon. As for the hole itself, it will likely outlive the stars, existing for 10 to the power of 67 years, before it finally evaporates via Hawking radiation in one last bright explosion. 2. Intermediate mass black hole, the missing link. Next up, we have the Bigfoot of astrophysics, the intermediate mass black hole. We call it the missing link because it theoretically has to exist to explain how giants grow, bridging the gap between small and supermassive holes. But we almost never find them. A strong candidate is HLX1, but generally they are elusive. They likely form from the merger of multiple stellar black holes in dense star clusters, or the collapse of massive gas clouds in the early universe. Visually, they would look just like their stellar cousins, only scaled up, perhaps the size of a planet. But the problem is they are masters of hide and seek. They often lurk inside bright star clusters, and because they aren't actively feeding, they remain essentially invisible. Their fate is usually a one-way trip. Over eons, they tend to sink toward the center of their host galaxy, eventually merging to become supermassive black holes. But until then, they can live practically forever. If you are unlucky enough to encounter one of these in a star cluster, you probably won't die immediately from the hole itself. Instead, you become the ball in a cosmic game of pinball. The chaotic gravity of the many surrounding stars will fling you wildly back and forth, battering you across the cluster until you finally get too close to the hole and are swallowed whole. 3. Supermassive black hole. And then we come to the bosses of this category, the supermassive black holes. These monsters sit at the center of almost every galaxy. We have Sagittarius A in our own Milky Way, and the Colossus M87, which became world famous for being the first black hole ever photographed. We are talking about millions or billions of solar masses here grown over eons by eating gas, stars, and merging with other holes. They are the majestic anchors holding entire galaxies together. To look at one is to see a gigantic shadow, often crowned by a massive rotating disk of glowing plasma, sometimes shooting particle jets light years into space. They are the ultimate survivors, destined to live for a mind-boggling 10 to the power of 100 years, long after all the stars have gone out before finally evaporating away completely in the distant black hole era, leaving a truly empty universe. The death here is paradoxically much creepier than with the small holes. We call it the silent horror. Because these holes are so gigantic, the event horizon is huge and the tidal forces at the edge are surprisingly weak. You wouldn't get spaghettified. You could actually cross the event horizon alive. You would fall in, turn around, and see the universe behind you shrinking until it vanishes completely. You would still be alive, fully conscious, but you would have left reality forever. You would fall for hours or days in absolute darkness until you finally hit the singularity, and no one on the outside would ever know what happened to you. If you are enjoying this existential crisis so far, please hit that like button and consider subscribing. It genuinely helps the channel survive against the void. Also, there is a new feature called Hype. If you want to really help this video break out, please go ahead and click that Hype button. It makes a huge difference. Category 2, the extreme scales. Here we leave human imagination behind. The scales become eerie. 4. Ultramassive Black Hole. Now we leave the normal monsters behind and enter the realm of the Titans, the ultramassive black holes. The reigning champion for a long time was Tan 618. You don't get this big just by casually eating stars. You get this big by eating other monsters. These Titans form from the violent merger of entire galaxy clusters where supermassive black holes collide and consume one another to build a single terrifying object. Visually, this is rarely just a silent shadow. It manifests as a quasar, shining with the intensity of 100 trillion suns. Oh, blindingly bright, it outshines the entire galaxy that hosts it. The event horizon itself is enormous. It is physically larger than our entire solar system. If you tried to visit one, spaghettification would be the least of your worries. You would die a radiation death. The accretion disk is spinning so fast and is so energetic that you would be vaporized by X-rays light years away, long before you even saw the blackness of the hole. They are the true immortals of the cosmos, living for over 10 to the power of 100 years, destined to dominate the cold, empty void long after every single star in the universe has burned out. 5 slabs, stupendously large black holes. And finally we reach the absolute limit of physics. The new king of this category is Phoenix A. And to be clear, this isn't science fiction. We didn't just invent this number. Astronomers found evidence for this monster lurking in the center of the Phoenix cluster. This entity is likely the final monstrous product of massive direct collapse events in the early universe. Visually, it defies human comprehension. It isn't just a dot in the sky. It is a hole in the universe itself. A blackness so vast that if you flew up to it, it would fill your entire field of vision, blotting out the sky completely. Its existence creates a problem for science. We actually have to adjust our mathematical models of early universe growth just to explain how something got this big this fast. It is effectively the longest-lived object in the known universe. Falling into Phoenix, it triggers pure megalophobia. But the death is even stranger. As you fall toward it, the extreme gravity causes massive time dilation. Time outside passes wildly fast, relative to you. While you fall, you could look back and watch the entire universe age, burn out, and fade into darkness in your rearview mirror. You would die alone as the last witness of all existence. Wait a minute. Everything I just showed you, those were simple, perfect spheres. But in reality, the universe is messy. Everything spins. Forget the static spheres. This is what the truth looks like. 6. The reality. First, let's correct the shape. The Kerr black hole. In nature, almost everything spins. Planets, stars, and galaxies. So, when a star collapses, that spin doesn't disappear. It gets faster, like a figure skater pulling in their arms. The result is that 99% of black holes aren't spheres. They are flattened oblate spheroids like squashed pumpkins. Inside, the truth is even stranger. The centrifugal force is so strong that the singularity can't collapse into a point. Instead, it forms a regularity, a 1D ring of infinite density. This creates a region called the ergosphere, where space itself is dragged around faster than the speed of light. If you fell in here, your death isn't simple compression. You would enter a region where time and space swap roles. Theoretically, you could fly through the center of the ring without hitting the singularity, potentially emerging in a different universe or time. But don't get your hopes up. The interior is unstable. A Kachi horizon of trapped energy would likely fry you in an instant, turning your journey into a lethal time travel. So, that covers the monsters we know exist. In part 2, we are leaving reality behind and entering the realm of the impossible. Make sure to subscribe so you don't miss it. See you in the void.